Today we're looking at absolute value functions. We're going to graph absolute value functions. Let's start with the most basic of absolute value. Now let's just remind ourselves what an absolute value does to a graph. If I have the absolute value of 3, that is asking me how far away is 3 from 0 on the number line. It is 1, 2, 3 units away. So the absolute value of 3 equals 3. Now, if I have the absolute value of negative 3 is 1, 2, 3 units away from 0 as well. So that is also equal to 3. So absolute value has a lot to do with distance. So the plane graph of the absolute value of x is called the parent graph or parent function for an absolute value. The graph of an absolute value function is shaped like a V. It just kind of looks something like this, and it's going to go in both directions. It's a V-shaped graph. So let's just pick some points. Let's start with -2, -1, 0, 1, and 2. Those are the numbers closest to 0, because you'll see kind of at 0 is where the bottom of the V is going to be. Now, if I take the absolute value of -2, that's going to be 2 units away from 0 on the number line. The absolute value of -1 is 1 unit away from 0 on the number line. 0 is on 0, so there's no distance between 0 and itself. The absolute value of 1 is going to be 1 on the number line, and the absolute value of 2 is going to be 2 on the number line. Now, all of these are points. We have -2, 2 is a point, and we're going to go ahead and plot these: -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Now, keep in mind, these are not the only numbers on this graph. I could pick 1, 2, 3, 4, 5, 6, 7. I could go to 7 and put the absolute value of 7 would give me a 7, so I'd have the point 7, 7, as well as like I could do a -7 or a -6, and that would be a 7, or the absolute value of -6 would be 6. So I can put all of these points on, but it's going to make 2 lines, and they are going to go in both directions forever. So it's going to be this V shape, but it's going to continue. Now we have this origin, 0, 0, is the lowest point on this absolute value graph, and this is called the vertex of the graph. Right there. So that point where it makes is the lowest or the highest point is the vertex. Absolute value functions can be graphed using transformations of the parent graph, f of x equals x. Now, there are different things. You're going to see a graph that's going to look something like this. All of the different A, H, and K are going to do different things. So let's start with this A value. This is going to be a vertical stretch or a vertical shrink. So what's going to happen is it's going to make it very skinny, like this, or it's going to be very wide depending on the graph. So the bigger the number, so if you had like a 7, it's going to make it more skinny. Whereas if you have a number that's between 0 and 1, or 0 and -1, it's going to be like a little bit wider. The horizontal shift is this number here, and this horizontal h value is going to move it left and right, but it is going to do the opposite of what you think it's going to do. Now, the k value is the up and down value. That does not do the opposite of what you think it's going to do. So let's look at this graph. This one is all done for us. First thing we're going to notice is this +3. This is the left-right shift, but it's going to do the opposite of what you think it's going to do. So since it is a positive 3, the opposite of plus 3 is a minus 3. So that plus 3 moved it to the left 3. The minus 5 is the up and down, but it does not do the opposite. So this is going to be down 5. So what that did is it moved it from, went down 5. So this, we start at 0, 0, we go left 3 and down 5, and that is our new vertex. So that would be the vertex there. Wherever you put the vertex, you're going to draw right on top of that vertex just a dotted line up and down. This is the axis of symmetry. The axis of symmetry, it's not part of the graph, it's kind of a folded line that where all of the points are going to line up equally. Now the last part is this 1/2. This represents the slope of the right side of the graph. So we're going to start by going up 1 over 2, and we will put this point. Every point, you can keep going up 1 over 2, up 1 over 2, and you can connect that into a line. But every point on the right side is going to correspond with a point on the left side that is reflected over the axis of symmetry. So this graph is going to just create a V shape. Okay, so let's look at some examples. Let's look at number 1. We have a plus 2. This is the left and right shift. Since it has plus 2, it's going to do the inside the absolute value does the opposite of what you think it's going to do. So instead of going to in the positive direction 2, it's going to go into the negative direction 2. This minus 3 is the up-down shift, but it doesn't do the opposite. It's going to go exactly where you think it's going to go. So we went left 2 and down 3. And then you're going to put a point right where those intersect. So left 2, down 3. If there is not a number in the front, it is a up 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. We can just keep going across the graph. And then we would put our axis of symmetry right on top of that vertex. That's going to be our axis of symmetry, and then we're just going to reflect all of the points across the axis of symmetry to make a V shape. And I like to think of V standing for absolute value, V for value. So whenever you see an absolute value graph, you're going to have a V-shaped graph. Now, transformations are just what did we do to the graph? Well, we went left 2, and then we went down 3. Our domain for all absolute values would be all real numbers. We can write that as just a fancy R, or we can just write all real numbers. Our range is our Y values. Now the lowest point of our Y value is going to be at -3. That's the lowest point. Everything is above -3. So we're going to say the Y is greater than or equal to -3. -3 is part of that graph, so we're going to put an equal sign there. Now let's look at our transformations. For our transformations, this -1, remember that's the left-right shift. It always does the opposite of what you think it's going to do. It's in the -1, so we would do opposite, which is +1. +1 is going to go to the right, so we're going to say right 1. And the +3 is going to go up 3. So right 1, up 3. And we're going to put a point there. There is also a 2 in the front. That is going to be a vertical stretch. A vertical stretch by 2. We have our axis of symmetry is going to go right on top of our vertex. we start with the right-hand side. We make a slope up 2 over 1. Connect those lines on the right-hand side, and then we reflect them over the axis of symmetry on the left. And if you notice, it kind of stretched it out to make it a little bit thinner and narrower than our last graph. The domain is going to always be all real numbers for our absolute value graph. And our range, we look at the lowest point. The lowest point is a 3, and it's everything above it. So the y is going to be greater than or equal to 3 on this graph. Number 3, we have a plus 5. That's going to shift it up 5. This negative, it's going to just change it so that the slope is negative. So all that's going to do, that negative is going to change it from the v going up, straight up, to going straight down. So the negative is a reflection over the x-axis, but we can abbreviate this as ROXA, reflection over the x-axis. Let's start by going up 5. 1, 2, 3, 4, 5. Put our point. Our axis of symmetry goes right on top of that point. We have a 1/3 right before the x. That's a slope of 1/3. 1/3 is less than 1. So this is going to be a vertical shrink by 1/3. So our slope is -1 over 3. So we're going to go down 1 over 1, 2, 3. And you can do that again, down 1 over 3. Connect those points into a straight line. And now this slope has to be on the right-hand side of the graph. You can't put it on the left because the left-hand side is going to be reflected from the right-hand side. Our domain is always all real numbers. Our range, this time where it's going down, the highest point is going to be 5. So the y has to be less than or equal to 5 because it's going down. Number 4, we have 3 times the absolute value of x. Now notice there's no number going up and down. There's no number going left and right. So the vertex of this is going to be right at 0. Our axis of symmetry is going to go right on top of this vertex. My slope is up 3 over 1. So I can do a few points here for that up 3 over 1. That up 3 over 1 is going to stretch out my graph. We're going to reflect that over to the left-hand side, up 3 to the left 1, and connect it into a V shape. Let's go ahead and write the transformations. The only transformation is there's a vertical stretch by 3. Now we're going to look, you will have some homework problems that will have f of 2. This means we're going to take 2 and plug it into the function. So if I have 3 times the absolute value of 2, 3 times absolute value of 2 is 2. So this is going to equal 3 times 2, which is 6. So at 2, we should have the point where our x is 2, our y is going to be 6. And we want to just make sure that that point over 2 up 6 is on our graph. So when the x is 2, our y is going to be 6. So you can plug it in, or you can look at the x on the graph and see how high did it go up. 1, 2, 3, 4, 5, 6, and this would be 2, 6. So when you look at f of 2, you're going to put 6 in for that answer. Domain for absolute value are always all real numbers for the domain. Our range, we're looking at the y values. Y is always, the lowest point is 0, but it's always above that. So y is going to be greater than or equal to 0. On number 5, we're going to look at our transformations. We have our negative is a reflection over the x-axis. That's going to make it go upside down. Our minus 5 inside the absolute value does the opposite of what you think it's going to do. So inside the absolute value is left and right. So it says negative 5. So we're going to go in the positive 5 direction. 1, 2, 3, 4, 5. And this is going to be our vertex. Let's go ahead and draw our axis of symmetry right on top of that vertex. So everything is going to reflect over this line. We start with our slope. There's not a number in the front, so it's a negative. Let's make sure we put right 5 on our transformations. Our slope is down 1 over 1. So that's what it would look like on the right-hand side. On the left-hand side, it's going to reflect over down 1, left 1. And it's just going to keep going forever. Now it kind of looks like the left-hand side isn't quite the same as the right-hand side. It's just because this isn't as long. You could keep going and it would be identical on both sides. So domain is all real numbers. The range, the highest point is at 0, so y is going to be less than or equal to 0. So it's everything below that. Now let's look at our f of 6. We're kind of doing this in a backwards fashion. F of 6, I could take my 6 and plug it into the equation. So if I'm taking this equation here and I'm plugging a 6 in, I would have negative 6 minus 5 is going to be equal to negative absolute value of 1. Now the absolute value of 1 is 1, but the negative is not inside the absolute value. So we're going to keep the negative. Negative 1 is going to be our answer. So this would be the point 6, negative 1. If we looked at the graph, I go over 6, down 1, we have this point here. So if you're finding f of 6, you could also go 1, 2, 3, 4, 5, 6, and then you would have a negative 1. So your answer of f of 6, you're going to put a negative 1 as your answer there. So f of 6 equals negative 1. We're going to write an equation for an absolute value function with the given transformations. So my original graph, f of x equals the absolute value of x. If I want to go left 4, left goes inside the absolute value with the x. So left is in the negative direction, but we always want to do opposite inside that absolute value. So what that left 4 is going to do is it's going to add 4 f of x equals x plus 4. And then down 5 is going to do exactly what you think it's going to do. So I'm going to put a minus 5 for the down 5 there. And then left 4 is going to be a plus 4. It does the opposite, but the up and down is not opposite. Now the last one, we're going to take our original graph, f of x equals absolute value of x, and we are going to reflect it across the x-axis. Reflecting it just means it goes upside down, and that puts a negative in the front of this absolute value sign. Stretching by a factor of 2 is the slope. And that also goes in the front of the absolute value graph. So I'm going to move this over. I'm going to put a 2 in blue here, and that's going to go as stretching by a factor of 2. The next step is we're going to translate it to the right one. Right is in the positive direction. We always put left and right inside the absolute value. The right one plus 1, we want to do the opposite. So I'm going to put a minus 1 inside the absolute value there. Now the last step is the up 7. Up and down is at the very end, so I'm going to put a plus 7 at the end of this equation.